What is the difference between these two expressions, the y dx and d over dx? You might have been seeing these two expressions in calculus. I might have been wondering what they mean in essence, even though they are still the same, but they mean something different. So in this video, I'm going to show you the difference between them and what they mean. Let's say I have a function y to be equals to x cubed plus 4x squared. And the question says that find the y dx. What does that mean? And let's say you have another problem which says, or which is of the form d over dx of x cubed plus 4x all squared. What is the difference between this and this? A quick, easy way I like to use to differentiate these two expressions is that the y dx tells you what it is, while d over dx is like a command. It tells you what to do. But that of dy dx is like a statement that tells you what it is. Meaning that if you find the y dx, it means you have differentiate function of y with respect to x. While this one is commanding you to differentiate what you are having within the bracket with respect to x. I hope that is helpful. So which implies that if I should find the y dx, and what I'm going to do using the power rule is simply 3x squared plus 8x. And this tells me that I've differentiated the function of y with respect to x. Why this? Whenever I say this, it tells me it's a command that I should differentiate what I have within the bracket with respect to x. So this will also be 3x squared plus 8x. And this is the answer. So we can actually combine them. We can combine those functions together. So how can we do that? What if I have d over dx, then I have y within the bracket? What does this tell me? It's a command which tells me to differentiate what I'm having within the bracket with respect to x, which implies that I'm just going to replace y with this, I suppose. Then I'm going to have d over dx of x cubed plus 4x squared. So which becomes the same as the y dx. So that's just the difference. Their result is going to be the same. But when you have to find the y dx, it's like a statement. They ask you to find the derivative of that function of y with respect to x. But if you have an expression that says d over dx of a particular function, then in that case, it's a command, meaning that you should differentiate what you're having in that bracket with respect to x. Sometimes you might have a function being differentiated with respect to another variable aside x. So what am I saying? What if you had to differentiate, let's say, y squared with respect to x? What if you have to differentiate y squared with respect to x? You already know what this means. It's a command. It tells us to differentiate what we are having within the bracket with respect to x. Now, the result in this case, using a power rule, will become 2y. But this 2y won't be our final answer, as we are going to multiply it with something called the y over dx. And this is a concept called implicit differentiation, whereby you'll be differentiating a function with respect to something that is not similar to it. After the differentiation, you will need to multiply it with what you differentiate with respect to what you use to differentiate it. So, which implies that if you actually differentiate a function r, or let's say x squared, with respect to r, then this will become 2x, then multiply by the x over the r. So, why is the differentiation of x squared with respect to x equal to 2x? Because if we multiply it with the x over the x, it turns out that the x cancels out and you will be left over with 2x. And that's how it is. Which implies that if you had to differentiate a function of y, like y cubed, with respect to y, then your answer will still be 3y squared. Simple as that. Most especially, I don't know, maybe you have talked about or you have been taught related rate yet. When dealing with related rate, you'll be differentiating a particular function with respect to another variable. Most especially, you'll be differentiating it with time, with respect to time. Like you'll be asked to find d over the t of a function y cubed. In this case, the result will be 3y squared, then multiply by the y over the t. And that's how it is. Now it's time for a pop-up quiz. Let's see if you have been paying attention to what I've been discussing so far. Let's say you have a variable y to be equals to x cubed plus t to the power of 5. Y is a function of both x and t. Now let's say you are asked to find the y over the r. What would you do in this case? Meaning that you should differentiate y with respect to r. Since you already know what this means, it's like a statement, then you can turn it to a command, meaning that the y over the r is equivalent to saying that d over the r of y. Perfect. Meaning that I can turn it to a command that I should differentiate what I'm having within the bracket with respect to r. We have talked about that earlier. Now, the next thing we are going to do is to replace y with what is given to us. And I'm going to have d over the r of x cubed plus t to the 5. Now I can differentiate the function. So the derivative of x cubed with respect to r will becomes 3x squared, then multiply by the x over the r, plus the derivative of t to the power of 5 with respect to r will also become 5t to the power of 4, then multiply by the t over the r. And this is my final result for the y over the r. Now you know how to work with differentiation of a function with respect to another variable. Hopefully you find this helpful. If you haven't subscribed to my channel, please feel free to do that now. Thanks for watching. See you guys in the next video.